Hey, welcome back. So last video, we investigated vertically scaling our application. We went through a bunch of EC2 instance types, whether that was storage optimized or CPU optimized or memory optimized. And at the end of that video, we scaled up the instance type to see kind of the performance differences. So vertical scaling certainly has its place, but there's another option. We're going to look at horizontal scaling in this video. These days, we have a lot of options in the cloud that kind of manage this scaling behind the scenes for us. So there's auto scaling features and there's, elastic load balancers and all of these features in kind of the cloud that we can just leverage. But I always like to start with fundamentals. So in this video, we're going to go back to fundamentals and we're going to look at using Nginx to horizontally scale our application. If you like videos like this, be sure to like and subscribe. As always, I think it's important to kind of review, the path that we've traveled along and kind of explain to where we're at right now. So we've got a lot of videos in this series. There's a monolithic deployment where we spent 8 videos just deploying this thing monolithically, and it was a very manual operation. Then we introduced some DevOps tools where we automated a lot of that deployment, and we have a CI/CD pipeline now. And then we started talking about scaling. We broke our application up into tiers. So we had a database tier, a worker tier, and a web tier, and a caching tier. And then we talked about scaling those tiers individually. Right now, we are here in this web scaling tier. There's already 2 videos on this. The first video that we had in this series, we took a deep dive into how can we get the most performance out of our web application without scaling. So we just looked at, turning on, for example, opcache for PHP, or using PHP Artisan Optimized for Laravel so that all of those kind of config and environment variables can be all cached. The last video we did, looked at vertical scaling, and we took a look at the options of grabbing bigger and bigger instances. And so we did that the last time. In this video, we're going to start looking at horizontal scaling. In the last time, we introduced kind of a testing framework, and we're going to do the same testing framework in this case so that we can kind of compare apples to apples. I don't want to change how we're testing everything. All right, so we have this Laravel application, and we're not going to spend too much time on this, but we have this demo app that we've been, we've already deployed it. It's there. It's what we've been using for this. This is kind of the architecture behind it. It has, Laravel is a PHP framework, so obviously there's PHP, but we're using Nginx as a front-end proxy between the requests and the fastCGI gateway. And then we're using PHPFPM for that gateway. And then you can see we're using MySQL for a database, but later on we switched that from a self-hosted MySQL instance. Now it's an RDS instance. And then we're using Redis as our cache. And that's now an elastic cache instance. We started off with a monolithic deployment, but we're no longer here at this level. Right now we have this 4-tier deployment where, again, I've already talked about the elastic cache is our Redis cache. Amazon RDS is now our database tier. We have our worker tier kind of in its own EC2 instance, and we have this web tier, which is what we're going to horizontally scale today. So if we take a look at the current infrastructure, we have a user that has a request. Right now we have Route 53 that's routing that request to our internet gateway into our virtual private cloud. And then we have a single EC2 instance, which is our web tier, that is responding to that request. And obviously that current EC2 instance is in the public subnet, so that can be reached as a public IP address. We also have a private subnet where we have our worker tier deployed, and then we have these RDS and this elastic cache instance, which are kind of deployed and they're accessible by anything on our VPC. The other thing I have shown here is the NAT gateway, and that NAT gateway is important for our instances in our private subnet so that they can access to the internet going outbound traffic. So when I do apt updates, they come through the NAT gateway, through the internet gateway, and out to kind of the internet to grab the data, and then it pulls it back in. Okay, so now let's take a look at where we want to land today. So this is where we're at, this is where we want to be. And we'll start in the public subnet. So there's no longer a web tier in our public subnet. So what we have there now is a load balancer. And what we're going to use for our load balancer is Nginx. And today we're going to go through deploying that load balancer and configuring it. And the purpose of that balancer is as requests come in, it kind of balances them out between the different web tiers that we have. And at the bottom in the private subnet now, we can see that there's 5 web tiers. Obviously, you can horizontally scale this to 150, whatever you need for your application. But we are just going to scale it up to 5 today. And we're going to measure the performance of 1, 2, 3, 4, and 5 just to see how our application scales as we add new web tiers. Everything else is still the same. So we have an RDS instance, we have Elastic Cache, and EC2, the worker tier here, and our NAT gateway is still there. I covered this in the last video, but I just want to briefly touch on this. The request response pathway, it now looks like this. So before we didn't have this pink box at the top. So a request would come directly into our web tier, the Nginx server, and then it would be proxied over to our PHPFPM, and then that would start to interact with the PHP code, which is Laravel in our instance. Laravel would interact with any kind of data tier, so either Redis or MySQL, and then the response would start to travel back up the same path. Now we have this load balancer. So we have a totally different Nginx instance, and it's acting as a load balancer, so it will balance out between a number of these different web tiers. So this dashed box is no longer a single box, it's multiple. And I'm not going to cover this. We talked about this in detail the last time, but there's a number of different test case. We're just going to use the same one that we did last time, which is a practical one. We're going to use our /login as our kind of our test endpoint. We also covered kind of what we expect from this. Ideally, as our requests per second kind of ramp up, we're going to go from kind of 0 requests per second up to like 3,000 requests per second. And then what we're going to get from the system is I'm expecting 0 errors. So the system should return 0 500 errors or 0 400 errors or whatever other kind of error. There should be no errors down here. And then our response time will kind of linearly increase as our requests per second. So as that load increases, we're still expecting that the response time increases. Practically then there's some threshold that above that threshold, users aren't going to sit around and necessarily wait for my pages to load. And this is typically sub-second for web pages. And so we kind of want to know what that threshold is for our application. And again, I'm not going to cover this. We talked about kind of squeezing the performance, optimizing that for different EC2 instances last time. And we tweaked these Nginx parameters when we vertically scaled. For a given EC2 instance, I'm going to use the parameters that we found the last time. So whatever we found that was optimal for Nginx, for a certain EC2 instance, those are the numbers that I'm going to plug in for our load balancer and also for our web servers. And same thing for the PHPFPM configuration. I'm not going to go through kind of optimizing these numbers. We already have the optimal numbers and we're just going to plug them in. We talked about testing in general last time. I'm not going to cover this, but again, we have these device under tests and we want to be careful how we do our tests. And we're going to do it the same way as we're going to use loader.io. This is our testing process. And so what we're going to do is we're going to do exactly the same test as we did last time. And that way we have kind of an apples to apples comparison. We'll be able to compare vertical scaling versus horizontal scaling. And we'll even look at the cost differences. If I choose to vertically scale versus I horizontally scale to that same kind of performance, what's the cost differences? Let's take a theoretical look at some cost differences. The last time we looked at vertically scaling this C7i instance, and we went from large all the way up to 8XL. As we obviously got a larger instance vertically scaling here, our costs went up. We got more specs, so we have 2 vCPUs to 4 CPUs to 8 to 16 to 32, and our amount of RAM went up. And then we have this metric that we measured last time from 0 to 3,000 requests per second. What was the average response time? And we can see as we scaled up, the average response time went from around 11 seconds to less than a second at 3,000 requests per second. And so, for example, to achieve this sub 1 second response time, I'm paying about, in this case, I'm paying $1.42 or $1.43 per hour. Now, what horizontal scaling gives us is we can take a number of these, for example, less expensive instances, and we can have that serve up a web tier. And we can balance the load between them. So for example, here is an example where we have just one of those instances, but we can horizontally scale up to 5. Here's the total cost. It's about 9 cents an hour. If we have 5 of them running, we're at about 45 cents per hour. The number of CPUs, I went from 2, and then if I have 5 of them, I got 10 virtual CPUs and about 20 gig. And look at our theoretical response times. So it went from 11 seconds, and this is just theoretical, but we'll see what the real numbers are looking like. But if you assume, for example, that 2 instances, I should get probably half of this time, and then 3 instances will be about a third of this time. And then by the time you get to 5 instances, we're already sub 1 second. So you can see to get the sub 1 second performance, I'm about 45 cents an hour compared to $1.43 an hour. And so that's one of the advantages of maybe horizontally scaling. So I can use kind of these cheaper commodity type instances instead of using one big instance. So at this point, we've kind of gone through all the background. Let's go ahead and get into our AWS console and start working on this. So now we're looking at our AWS console page, and let's just kind of see where we're at right now. If I look at my RDS instance, I have an RDS instance, it's up and running, and you can see it right here. And it has 2 connected EC2 instances. One of these is the web tier, and then the other is the worker tier. That's our RDS instance. If we look at our caching instance, look at Elastic Cache, we have a Redis cache, a single one of those. You can see that that's up and running also. And then the last thing we'll look at was look at our EC2 instances. Currently we have 2 of them running. We have the worker tier and we have the web tier. We're not going to touch the worker tier today. We're just going to leave it running. It's currently a T2 micro. We're not going to do anything with that at all. And in the previous video, we took a look at vertically scaling this C7i instance. And that's what we're going to look at today, horizontally scaling this C7i.large instance and see if we can get the same performance as, maybe the C7i XL. So that's our goal today, is we're going to switch all of our web tiers to the C7i large, and we're going to see the performance as we horizontally scale those. We're going to take incremental steps to get this to where we want to be. The first thing I'm going to do is I'm going to take this T2 micro, I'm going to shut it down, and we're going to restart it as a C7i large. So let's do that right now. So I'll select it. I'm going to stop it. Okay, now that that instance is stopped, we are going to go to our instance settings and switch the instance type. And again, we want that C7i.large instance. And if we just compare that T2 micro, this is vertically scaling right here. We're going to go from 1 core to 2 cores, from about 1 megabyte of memory to about 4 meg. And so let's go ahead and do this scaling right here. And the reason I'm doing this is I want to be able to compare what we did last time when we vertically scaled that C7i to when we horizontally scale it. Start that up. All right, it has its public DNS name. I'm going to copy this. And just like last time, it's a different IP address. So we're going to have to change our hosted zone. Go ahead and edit this record. We'll put in this new address. Still says initializing there. We'll let that finish up. While that's finishing up, let's talk a little bit about this load balancer. And one of the concerns that we want to talk about is our SSL certificate. Right now, we know that the request is coming under HTTPS. So that request comes all the way through to here as HTTPS. Our load balancer, we're actually going to terminate that SSL certificate at the load balancer. And what that means is that all of this internal traffic is going to be HTTP. And that's perfectly fine in this case because the traffic between our load balancer and our web tiers, this is on our private subnet. No one gets access to that traffic unless they already have access to our VPC. And if they already have access to our VPC, then we're in trouble anyway. This is a perfectly fine situation. I want to terminate that SSL certificate at the load balancer. All right, if we go back to our instances, let's refresh this, and they're both up and running. If I go to my Laravel application, if I refresh that application, I get responses. Let's talk about what we see here. 2 things is I pick a random lat long, and then I just have some random data for places around the world, totally made up. So you can see I picked a 90,86 as our lat long, and then here's the nearest 10. So every time I do a request, new random lat long, and then I have to go and grab the nearest 10 locations. And then the thing you'll see over here is the host name. This is the host name of the web tier that's serving up this response. Later on, that's going to be useful because we'll hit the different web tiers and see how it's kind of load balanced. So at this point, we scaled our instance up to the type that we want. Now let's start configuring our load balancer. So one of the first things I want to do is I want to create an image from this current instance. It's currently running. I'm going to go under Actions, and under Images and Templates, we're going to create an image. And this is going to be our Laravel demo, and we're just going to put image in here. I think everything else will just keep it the same, and we'll go ahead and create this image. Now it takes a bit of time for this image to actually take this first snapshot, so we can go over here and we can see where it's at. We have the image, it's pending. Right here's where it says pending. We're gonna let that image snapshot there complete, and then we can use that AMI to provision all of our web tiers. Okay, so now that we have this Laravel demo image now available, we can use that image to provision a number of web tiers. So let's do that next. All right, so I got it selected, and I'm going to launch an instance from that AMI. And we're going to set this name to this. It's got the AMI already selected. It's not going to be a T2 micro. We're going to want these to be that C7i large. The key pair is we're going to use the key pair that we've been using all along. Update the network settings from the default to the demo one, and we're going to put these in our private subnet number 1. We're going to create a security group for this, and we're just going to name this. This is our demo web app security group. Put SG on the end so that I just have my consistency in my naming here. I definitely want to be able to SSH into it, and then I need to add one more rule here. I want to be able to allow HTTP traffic to this from, and we're just going to say anywhere again. And what this really means is, because we're on that private subnet again, anywhere really means you have to be within our subnet. So it's not anywhere like all of the internet. It's just you have to be somewhere on our private subnet or public subnet. I'll leave all this the same. And over here for the number of instances, we're going to say we want 5 of those, and we're going to launch this instance. All right, so if we go back to our EC2 instances now, I'm going to see our 5 new instances for the web. So I see 1, 2, 3, 4, 5. While these are spinning up, I'm just going to go ahead and start to name things a little bit better. This is going to be our load balancer. This one will be web. Oh, did it take that? I don't think it took my name. Load balancer. There it goes. Okay. And this will be web 1. And these are just mostly for us, so that when we're looking at them, we can talk about them. And they all have different names then. So we're gonna take a little break, let these things spin up, and then when we come back, we'll start to kind of configure everything. Because right now everything is still configured so that it's all coming into that load balancer, and we're getting the results directly from the load balancer, which is still kind of a web tier at this point. That's how it's configured. But when we come back, we'll start to configure this as a load balancer. We'll have it send the request to our 5 web tiers. Okay, so we're back, and all of our instances are now up and running. And if you recall, I mean, these web tiers, all 5 of these, they're not in the public subnet, they're in a private subnet. So in order to SSH into these, I have to use the load balancer instance as a jump box. So we're going to log into each of these web tiers and get them configured. So right now I have a terminal window open, and we're in a directory on my desktop, and inside that directory is my private key. So we're going to SSH in using that private key and the Ubuntu user, and we'll go to our IP address for our load balancer. That's our public IP address. It's a brand new server, so asking us if we recognize this one or not. Yes. And so now we are on our load balancer. From here, I can SSH in using the same private key, but I've already staged this. In previous videos, I had this already staged. It's in my .ssh directory inside that instance. And it's the Ubuntu user. We're going to grab our IP address for our web 1. And so it's a private IP address. And we'll paste that in and we'll connect. Again, first time, so we'll say yes. So now I have a connection to my first web tier. So first thing we're going to do is we're going to look at our Nginx conf. And in our previous video on vertical scaling, we optimized all these values. So I just want to make sure that I'm putting in the values that we figured out that were the optimal ones. So for worker processes, we set it to 2. 2,000 was the file limit. I should say 20,000 was the file limit, and 10,000 was the number of worker connections. So that's all fine there for Nginx. All right, next thing I want to look at is I actually want to look at the sites available and our demo conf. And we're going to make a few adjustments here. And the first thing I'm going to do is at the very top of this, I'm just going to listen. I'm going to add a listen directive to port 80. And then I'm also going to change the name. I'm not sure if the name is going to come through, so we're just going to set this kind of as a catch-all. We'll just put it as an underscore. We'll leave all that the same. It's all going to be the same. We're using that PHPFPM socket still. That's going to be on this computer. Here's where we can start to make some changes. We are not going to handle any SSL certificate, so we're going to get rid of these lines here that were added by Let's Encrypt. And then same thing with this extra server directive down here. This is added by Let's Encrypt to redirect port 80 request to port 443. So we're just get rid of all of that. And I think, compare with my notes, I think we're all set on this. So I'm going to go ahead and get out of here. We'll save this. Anytime you make changes to Nginx, you should always do the sudo nginx-t, and it says it's okay. So we'll go ahead and restart that now. Now I want to look at the PHP configuration. So we have our demo 1 pool. It's run under demo 1, group demo 1. The listen directive is still set to run under the socket. And that's okay, because if you remember the stack, we have Nginx running on this EC2 instance, and that is going to connect to this socket, which is on the same instance. So using a Unix socket here is okay. So we'll look at our optimized parameters. So we set this to static. We're going to leave it as static. And we set the total number of children to 20, and that's okay. And then we set the max request to 10,000. So that's all good. All right, we didn't make any changes there, so we're just going to leave everything the same. In fact, just to be safe, we'll just restart PHPFPM. Okay, so I have this window. This window's open to kind of the first web tier. I'm going to add another tab to this. And now we're going to do the same process again for the other 4 web tiers. Okay, so I have a tab open for every single one of our web tiers right now. So from left to right, this is web tier 1, web tier 2, web tier 3, web tier 4, and web tier number 5. I've also made all the changes to Nginx and PHPFPM, so all of our web tiers should be configured and ready to go. All right, so the next thing I'm going to do is let's configure our load balancer. So we're going to connect to our load balancer, which is at that IP address. And the very first thing I'm going to do is we no longer need PHPFPM running here at all. So we're just going to shut that service down. Okay, so what we're going to do next is we're going to look at a new conf file. So I already created a conf file for the load balancer, and we're going to go through line by line what they are. But right now that conf file is located here under sites available. So we're going to go ahead and get in here and take a look. So at the very top, there's an upstream directive where I define an endpoint called web. We're going to call it web app. And under this upstream directive, I have 5 servers defined. And these 5 are the IP addresses. These are the private IP addresses of all of the web tiers that we just provisioned. So we just got done setting those up. I copied and pasted all of the IP addresses in there. And so we have all the IP addresses. And then there's 2 server directives. There's one at the very bottom here. We'll take a look at that one first because that's easy. This is the server directive that Let's Encrypt added before, and all it's doing is it's taking all the requests that are directed to port 80 and it's redirecting them to HTTPS or port 443. Then the server directive right above that, this is where our requests from our users come in. So they come into this load balancer, and a lot of this is the same. So you can see that we have a server name directive, but what we no longer have is we don't have a root directive anymore because we're not really handling the request on this server. What we're going to do is we're going to use the proxy pass, and we're going to pass this request over to our web app. And our web app, again, is defined here at the very top. So you can see that. And what Nginx is going to do for us is it's going to round robin by default through these IP addresses, select an IP address and send a particular request over to that. Nginx has some directives that you can include in here. So I could include a directive in here to set the load balancing algorithm to something different. As an example, there's a least con directive, which in this case, Nginx would direct the request to the server that has the least number of connections. There's also directives like least time, and there's a few others. I'm not going to use any of those directives for now, but just know that they do exist. And by default, what will happen is Nginx will just round robin through these things like they were all independent. So we jump back down to the server block again. That's where the proxy pass is coming in. The proxy pass is passing a request over to one of our web servers. And it's also proxying over some of this other data that you see here. Right above that, you do see that there is a location. It has a very specific one. So if this endpoint is requested, which is a loader.io file. If that loader.io file, then serve it up directly from this load balancer. That's what we're doing in this case. So I put this file directly on the load balancer and serving it up directly from here. And what that file is for is because loader.io, which is the service that we're going to use for testing, it requires this file to be present on your server, and that way it knows that you own that server and you're not just kind of spamming some server that you don't know. And we're going to serve that up directly from our load balancer. Below our proxy pass one, you can see the standard Let's Encrypt information that it put there for our SSL cert, and we already covered that redirect. So this is our load balancer one. Okay, so what I want to do now is I'm going to comment out all of the web tiers except for the very first one. We're not really scaling out or doing anything horizontal scaling. We just have a load balancer and a single web tier. And I want to make sure that that's functioning before we move on. And if I look at, let's see, our Nginx sites enabled directory, I don't have the load balancer here. I have just the web app. So I'm going to go ahead and remove that one. And we'll create a new one. So now if I list the ones that are there, we have the load balancer. Okay, so we made some changes to Nginx. Let's check out, make sure everything's good. That looks good. We'll restart Nginx. Okay, so we should be restarted. Okay, so we have our load balancer set up. I'm going to go ahead and refresh this. I'm not expecting this to work yet, and I'll tell you why in a second, but let's go ahead and refresh it. And what we're going to see here is this is just going to time out. And the reason it's going to time out is it's trying to hit the database. And if we go back to our RDS instance, our RDS instance has these connected compute resources. So right now, we have two connected compute resources. It doesn't really label them well here, but one is the load balancer and the other is the worker tier. And so what I need to do now is we're going to add all of the EC2 instances that we just created for our web tiers. So here's web 1. We'll add that in. And then when we look at it, we'll see down here, there should be another connection. So we're going to repeat that process for the next 4 web tiers. So we did web 1, here's web 2. And finally web 5. So now it should be 1, 2, 3, 4, 5, 6, 7. So our 5 web tiers in our original 2. So now that those connections are there, when I go and refresh, now this should work. And you can see right now it's functioning as we expected. The IP address isn't really changing. It's only hitting one of our endpoints. So our next step is to actually collect our data. We want to horizontally scale from 1 instance to 2 to 3 to 4 to 5. Run our loader.io test, the same thing we did last time. Let's collect those numbers. So I've got that set up in our spreadsheet here, and you can see in this column I've got the scale set up from 1, 2, 3, 4, and 5. We're not going to change these instance values. So all of these numbers right here that I highlighted in that square, those are going to be constant. We did that last time, kind of optimized and tweaked. But what we're going to do now is run our 0 to 3000 test, collect our numbers. Right now we're set up for this top one, and we're going to do that next. The other windows I have this window open so I can see kind of to make sure the website's working. We have our loader.io test here. And if we look at that test again, we are going to go from 0 to 3000 clients. We're hitting our login endpoint, so that's the one we're going to do. And the other windows that you can see kind of just off the edge here, so I can quickly switch to them, are we have a terminal window here at the very top. This is our load balancer terminal window, and we're going to put glances running there, so I can see kind of the CPU and everything that's running. And then here at the very bottom, I have 5 tabs open. This is the first web tier, and we'll run glances there. This is the second web tier. We're going to go and start glances up on that one. This is the third web tier. We'll run glances here. The fourth one. And we'll do the 5th one also. So what I'm going to do is after I start this test up, I'm going to actually just kind of take a quick peek at glances on both the load balancer and also the web tiers just to see what the CPU and the memory levels are like. All right, so we're ready to kick off our first test. Again, this is tests of 1 instance. So it's already started. Over here we can see our load balancer CPU. We can see the CPU of our instance. We only have one instance configured in the load balancer, so I'm not expecting these other instances to be doing much of anything at this point. They're just kind of idling. But our first instance is ramped up 100% and it's handling all the requests. So we'll let this finish up. We'll collect our data and see what our numbers look like. Okay, so we have our first test done. And if you recall, we collected this average number. We'll stick that in here. And we also collected this max number. And we'll stick that in here. Now, interestingly, we've already kind of tested this before, right? Here's our C7i large, and these are our numbers for that. So we see about 22.6 and 11.3, 24.8 and 12.3. So it looks like possibly there's a little bit of overhead just because of the load balancing going on. We have another layer that we have to go through. So that's going to add a little bit of overhead here. But now let's scale it up to 2 instances and see what our number looks like. All right, to scale it up to 2 instances, we are going to modify that load balancer file that we already looked at one time. And we've already set ourselves up, so I'm going to uncomment it. We're going to restart Nginx, start up glances. So now we're going to do this test here. And we're all set, so let's go ahead and kick off that test. All right, so it's already running here. And what we see is our load balancer is at 4.9%, memory 15.7. We can see that our first web worker is at 100%. Our second web worker is also at 100%. Our third one, our fourth one, and our fifth one should not be, they should just be idling. But our first 2 web tiers are handling those requests right now. We'll let this finish up and we'll copy in our results. All right, so we're all done. We are going to copy this over to our worksheet. So you can see, scaling from 1 instance to 2 instances, I didn't quite have it. It's about 60% of it, something like that. And my gut feeling is that there's a little bit of additional overhead with the load balancing going on. All right, so we're going to scale up to 3 instances. So we should be all set there. Kick off that test, we'll let it run. All right, looks like it's started here. Go over to our glances. You can see our Nginx load balancer is running about the same level it was before. Here is the first web worker, it's 100%, the second one's at 100%, and the third one's at 100%. 4 and 5 are just sitting idle because they're not really configured yet. We'll let this complete and we'll copy in our results. All right, again, we've improved our performance. Didn't have it, so at this point we are about 4709 out of 12,395. Tripling our instances gave us about 2.6 times the performance. And I should say, I'm also looking at those details. Right now there are no errors, no 500 errors, no timeouts, nothing going on with our networking. So we're getting replies from all of the requests, which is what we want to see. All right, so let's switch it over to 4 instances. We should be set to kick off this test. Let's go ahead and start a new one. So it's prepping the test, it's going. Let's take a look at our instances here. So our CPU from that one, this is what we expect. Our first web tier is working 100%, second tier 100%, third tier pretty close to 100%. Our fourth tier is at 100%. So everything is functioning like we thought, and the fifth tier is still idle because it's not really configured yet. So we'll let this finish and we'll copy over our results. And again, our numbers have improved. All right, we're going to configure our last server, and we'll scale up to 5. All right, we should be all set to run this test. So we're going to kick off the test. All right, it hasn't updated yet, but the tests are going. I can see 100% here. Our load balancer is operating at the load that it was before. It's the same load. Now it's Now it's directing traffic between all of the workers. This middle worker, it's taking it easy on that middle worker. I'm not quite sure why it's not hitting the full 100% all the time, but that is interesting. It's kind of sparing it from the 100% that everybody else is getting. All right, the test is completed. Let's go ahead and copy in our results. Okay, so let's take a look at our results here. We got all our numbers. I put a chart here at the bottom. That chart has two pieces. The first part is the chart from when we just vertically scaled. So I copied that over so you can see kind of those numbers. And then the second half, the right half, is our horizontal scaling results. As you can see in both cases, is either we vertically scale or we horizontally scale. The bars are getting smaller. And smaller is better performance. So what we're plotting here is this average response time. And you can think of this as, our response time, we're ramping from 0 to 3,000 requests per second. So you can kind of think about this as this is about when we're about 1,500 requests per second. What's our response time? So with one instance, our response time here is about 12.4 seconds. When we're getting 1,500 requests per second, each user is waiting about 12.4 seconds. And if we compare that to our previous testing when we didn't have the load balancer in, is around 11.4 seconds. So it's about 1 second overhead, it looks like, for whatever the additional stuff is. That feels a little heavy. It feels like maybe there's something in there that shouldn't be taking a whole second, but it is what it is. That's the test that we just ran. Also, as you look and we scale up to, say, 5 instances, we're down to around 3 seconds a request. Our load's about 1,500 requests per second, and every user is getting about 3 seconds per page. Is that acceptable? I mean, if that's our steady state load, is that 3 seconds a request is not acceptable. You want to get sub-second. And if you recall, I started this video off by saying that we're not going to use kind of the fancy infrastructure that's there in the cloud for us to auto scale this. We're just doing it manually. So that's what we're talking about right now, is just manually scaling. In the next video, we'll cover some of the fancy features where we can auto scale. So in this video, I'm not going to scale this up anymore, but presumably we could add more instances and drive this down below 1 second. And every time I add an instance, I'm adding about 9 cents per hour. And then you can see to beat this 3 second request time, I would need to get up to a 4XL over here when I vertically scaled. So let's go look at the price of the 4XL. This is costing me about 45 cents per hour. What's that 4XL? If I want to beat that, that is going to cost me about 71 cents per hour. So you can see already, yeah, I would get more performance. This is a little bit better than that, but I could just continue to add more. So there is some advantage to adding these commodity servers. Now, vertical scaling, horizontal scaling, you don't have to do either or. This can be a combination of both. We already know that we scaled this vertically from a T2 micro to a C7i because I wanted to be the same class. And that's what you would do in a real application is you would pick your server, figure out what the vertical scaling, how much you need per web tier. And now you can also scale that horizontally. All right, so it's the next day, but there's a few more tweaks that we should really look at here. Right now, we have this kind of stack going on. We have a load balancer with Nginx, and it's proxying the HTTP requests to another Nginx proxy, which is proxying it to the PHPFPM. And then it's going to Laravel and our data tier. One change that we can do is we have these 2 layers of proxying. We have HTTPS coming in here, HTTP coming out, and then it's the fast CGI or FPM process going from there. Anytime you can remove something from your stack, it's going to be faster. There's just less things that have to be done. So we're going to transition over to this stack here where we've removed this Nginx proxy. Everything in the dash line is what's on our web tier, and this is kind of our front load balancer. So our load balancer is going to actually proxy FPM requests. We're going to set that up now. Okay, so I still have the same kind of setup. I still have these kind of terminal windows open. The top one is a single instance. There's only one tab here, and this is a connection to my load balancer. And at the very bottom, I have 5 connections or 5 tabs open to all the web tiers. So first of all, let's take a look at the web tier and what we've changed. For each one of these, I've already kind of made these changes, but we're going to review the changes. So the first thing I did on each of these web tiers is we no longer need Nginx running. So I just shut Nginx off. I stopped that service. And the second thing I did is I updated our PHP configuration. I'll show you the changes there. And it's a pretty small change. And if you recall, in the past, we've been using kind of Unix sockets because they're faster. Another option that you can have is you can actually use a TCP connection. And so we're going to switch over to TCP connection because that makes it available from another server. So this is my first web tier. And if I go to my EC2 instances here, you can see my first web tier is right here. And that instance has a private IP address of 10.1.134.4. And so in my PHPFPM configuration, I'm listening on 10.1.134.4 and on port 9000. And I've commented out the socket or the Unix socket connection. So now we're using TCP connection to connect to all these PHPFPM servers. I did that on every single one of these web tiers. I shut Nginx off and then I updated the PHPFPM to use that TCP socket, and each one has their own independent IP address. So those are the changes I made on the web tier, and I did that again for all 5 of those. So up here in the load balancer, again, we don't have PHPFPM running, so that process was already turned off the last time. It's just an Nginx proxy here. So now let's just take a look at the Nginx configuration that we got. So first of all, nothing here is changing. I just want to show this because I want to make sure that we're all on the same page. These are the optimal values that we discovered through kind of an optimization process in the last video. So we'll just keep those all there the same. Everything else in this configuration file will scan through the whole thing, but there are no changes in here. So we still have the same configurations. gzip is still on. All that's just commented out at the bottom. To make this load balancer proxy not HTTP, but the proxy FPM requests, now we have to update our load balancer configuration file. Here at the very top, you can see now the server definitions. It has all the private IP addresses, and then I put the :9000 because that's the connection now that we're going to use. Some of the other changes that you'll see here is now there's a root element. And so that root element is providing the directory for where that PHPFPM is going to be finding the code. And one of the questions you may have is, what is this path? Is this a local path on the load balancer? Because the code is on the load balancer, but this is actually the remote path. So it's the path that's you're going to find on every web tier. And I did a quick experiment to make sure that that was true. So I updated a PHP file on the web tier, and I would get different results. So it's not serving the PHP from this load balancer. This is a remote path. Some of the other things that are important here is, again, I have this location for this loader IO. This is that token that loader IO needs to make sure that you own the site. And then here's where the big changes come in. Now, our index is an index.php page. We're using charset UTF-8. And this is kind of the standard Nginx setup for PHP when you're proxying PHP. Down here, we're using the fastcgi pass, and we're feeding the variable called web app. And again, that web app, that's defined in our upstream. So our upstream definition of web app is one of these servers here. And so the Nginx will provide an IP :9000. And so every single request will get proxied to one of those servers. Everything else is the same. We still have the Let's Encrypt certificate there. And at the very bottom, we have kind of a directive where we're redirecting any HTTP requests to the HTTPS version of that. Okay, so at this point, we've got all 5 servers connected up, and we're just going to run this demo test so you can see it. I already collected all the data. I'll show you the data in just a moment. But we'll kick off a test here so you can see this thing fire up. So at this point, we'll see the load balancer CPU firing up. It's using some more memory. Down here, we'll start with server 1. Here's server 1, 100%. Here's server 2, 100%. Here's server 3, 4, and 5. They're all involved in serving up these requests. And again, if you look at each of these servers, all we really have is the PHPFPM processes that are running. We don't have any Nginx running on this. Now I'm going to let that just run in the background. All right, so I've already collected this data already. This is the previous results that we had. So when we had the Nginx proxy in here, and now here's version 2, which has the Nginx proxy removed. I'll switch back and forth between these two tabs a little bit, but let's look at this one. This is 10 seconds for one instance, about 8 seconds. Here it's 12.4 seconds. Is all of that gain, is that all from just removing that extra layer? Part of it probably is. When we add 2 instances, we're at 7.3 seconds with the Nginx proxy in place. And over here, we're at 6.7 seconds. And so you can see kind of as you go down, it does improve the performance. So we removed a whole layer here. And so the performance is definitely better without that extra layer there. Okay, so we've accomplished what we wanted to do today. We got to this point right here. This is what our infrastructure looks like right now. We got the load balancer Nginx, and it's load balancing between our 5 web tiers. But there's things that aren't ideal about our situation right now. So for example, right now to spin up each one of these EC2 instances, we have an image, right? And we're spinning it up from an image. And that's okay, all right, but it's manual. Right now it's a manual process to scale horizontally. And what that process looked like is, we spin up a new EC2 instance, configure that instance, and presumably we could create a new image, right? So we could create a new image with all the changes that we had in there so that we wouldn't really have to do any changes to our EC2 instance. So maybe this is a new image, and that would result in maybe no changes. But you still have to kind of then add it to your load balancer. It's doable. It's not ideal. All right. So what I want to get to is kind of automate this a little bit more. And to automate this, I want to explore a few additional technologies. And we're going to explore these over the next couple of videos. So one is I want to deploy this via a Docker image. And to do that, we're going to have to look at the Docker container registry. And I think it's probably just DCR in Amazon. We'll also take a look at the Elastic Container Service, or ECS. And we'll probably take a look at the Elastic Kubernetes Service, or EKS. So once we understand kind of the technologies, those 3 technologies, we should be able to deploy our image and also incorporate into our CI/CD pipeline. So that's another thing we'll have to do. So instead of packaging it up into a zip file right now and then deploying that zip file, we will package it up to an image and automatically create that image and put it into the registry. And then when we do our deployments, we can pull that image and use that to spin up our new EC2 instances. So that's the plan with the Docker image deployment. After I get through kind of that Docker image deployment, then we have to circle back and start talking about auto scaling. Once we have the ability to point at an image, a Docker image, and just have it automatically create new EC2 instances from that image, then I think the auto scaling is going to fall into place. So we'll circle back to that. So that's our roadmap, I guess, for the next couple of videos. So if you are interested in that kind of content, hit that like button and subscribe, and I'll see you next time.